Sequence and series. Sequence is the list of numbers that follows a pattern or a rule. Examples 1, 2, 3, 4, and so on, where each number in the sequence is called a term. Series is the addition of the terms of a sequence. Examples 2 plus 4 plus 6 plus 8, and so on. Find the 10th and nth term of the AP 5, 10, 15, and so on. In this case, our first term is 5, and our difference is gotten by subtracting the first term from the second term, or the second term from the third term, which is 5. Recall, Tn is equals to nth term, which is a plus open bracket n minus 1 close bracket d. So for question A, to find the 10th term, which is T10, is going to be what? 5 plus open bracket 10 minus 1 bracket 5. So invariably, you just put in the values, that's the first term and the common difference, in the formula. Then for the nth term also, Tn is equals to what? 5 into bracket n minus 1 or close bracket 5. In this case, our answer is 5n. 2. Determine the number of terms, which is 83, in the AP 3, 8, 13, and so on. Here, first term is 3, common difference is 5, and Tn is 83. I'm looking for n, that's the nth term. Therefore, Tn from our formula is equals to what? A plus open bracket n minus 1 or close bracket d, where Tn is 83, then A is 3, and D is 5. So after inputting and summing all, we have our n to be what? 17. Therefore, the 17th term is what? 83. In an AP, the difference between the 8th and the 4th term is 20. And the 8th term is 1.5 times the 4th term. Find the common difference and the first term of the sequence. T8 is equals to A plus 7D, and T4 is equals to A plus 3D. Now the difference between the 8th and the 4th term is T8 minus T4, which is equals to 20. Now, which implies that A plus 7D minus all into bracket A plus 3D gives us 20. After solving, our D is 5. Now for B, 8th term is 1.5 the 4th term, which implies that T8 is equals to 3 over 2 T4, which now implies also that A plus 7D is equals to 3 over 2 into A plus 3D. After solving, we get our answer to be 25. Therefore, our D is 5, while our A is 25. Find the arithmetic mean of 20 and 26. Solution. Recall, B equals A plus C over 2, where B is the arithmetic mean. Therefore, 20 plus 26 all over 2 equals 23. If 3 consecutive terms of an AP are x plus 4, 2x plus 8, and 12, find x. Solution. Recall from A, B, C, where B is the arithmetic mean. We now have in this question 2x plus 8 to be the arithmetic mean. Therefore, 2x plus 8 equals x plus 4 plus 12 all over 2. On solving, our x gives us 0. Find the sum of the first 24 even numbers, and find the sum of the first 20 terms of an AP 17 plus 12 plus 7 plus so on. Now, solution. The first one, we have to find the sum of the first 24 even numbers. The even numbers are 2, 4 up to 48, where our first term is 2, our common difference is 2, and our nth term is 24. Therefore, S24 equals 24 over 2, all into bracket 2 into bracket 2, which is our first term, plus 24 minus 1, all into bracket 2. On solving, we have our answer to be 600. Therefore, the sum of the first 24 even numbers is 600. B. In an AP, 17 plus 12 plus 7 plus and so on. A is equals to 17, which is our first term. D equals to minus 5, which is 12 minus 17. And N equals 20. Therefore, S20 equals 20 over 2 into bracket 2, open bracket 17, which is our first term, plus open bracket 20 minus 1, all into bracket minus 5, which is our difference. On solving, we have our answer to be minus 610. Find the 8th and nth term of the geometric progression 10, 20, and so on. Solution. A equals 10, R is equals to 20 over 10 or 40 over 20, which is 2. Recall, Tn is equals to AR raised power n minus 1. Now for question 1, T8 is going to be equals to AR raised power 7 after inputting A 8 in the formula Tn. Therefore, on solving, we have our answer to be 1280. For B, Tn is equals to AR raised power n minus 1, where our A is 10 and our R is 2, which now becomes 2 times 5 times 2 raised power n minus 1, and also now becomes 5 times 2 raised power n minus 1 plus 1, following laws of indices, having our answer to be 5 times 2 raised power n. If the first, second, and last term of a GP are 4, minus 20, and minus 12,500 respectively, find the number of terms in the GP. We are looking for n. Where A is 4, R is minus 5. We have our second term, which is AR, to be equals to minus 20, and our nth term, which is AR raised by n minus 1, to be what? Minus 12,500. Now, AR raised by n minus 1 is equals to 12,500, where our A is 4 and our R is minus 5. Therefore, on solving, we have our n to be 6, which is the number of the term of the sequence. Find the geometric mean of 9 and 25. Solution. Recall, b squared is equals to root AC, where b is the geometric mean. It implies that b squared is equals to root 9 times 25, which is equals to root 9 times 25, which is equals to 15. The third term, fourth term, and fifth term of a GP are x plus 3, x plus 8, and x plus 18 respectively. Find x. On solving, x plus 8 is the geometric mean from b equals root AC, which implies b squared equals AC. Therefore, since x plus 8 is the geometric mean, we can equate x plus 8 all squared to the product of x plus 3 and x plus 18. On solving, we have our x to be 2. In a GP, the seventh term is 16 times the third term, and the sum of the second term and the sixth term is 102. Find R, A, and S8 minus S4. For the first question, T7 is equals to 16 T3, which implies that AR raised power 6 is equals to 16 AR raised power 2. Therefore, AR raised power 6 divided by AR raised power 2 is 16. And solving, our R is plus or minus 2, where R is positive. Therefore, R is 2. B. The sum of second term and sixth term is 102. It implies that AR plus AR raised power 5 is equals to 102. Now, A is common. Therefore, A into bracket R plus R raised power 5 equals 102. On solving, A is equals to 3. Now for C, S8 minus S4. That is the sum of the 8th term minus the sum of the 4th term, which is equal to A into bracket R raised power 8 minus 1 all over R minus 1 minus A into bracket R raised power 4 minus 1 all over R minus 1, since R is greater than 1. Therefore, A is 3 and R is 2 from our previous solution. So 3 into bracket 2 raised power 8 minus 1 all over 2 minus 1 minus 3 into bracket 2 raised power 4 minus 1 over 2 minus 1, which the answer is 720. Find the sum to infinity of the series 256, 64, and so on. Solution. A is 256, that's the first term. R is 1 over 4, which is the common ratio. Using S infinity, which is equals to A over 1 minus R, we have 256 over 1 minus 1 over 4, which is 256 over 3 over 4. Okay, which is also equals to 256 times 4 over 3, which is 341 whole number 1 over 3.